Hello students, welcome to the lecture on health, safety and environment, and after this lecture we will be able to learn the following objectives. Understand the health effects of pollutants, discuss about hazard in oil and gas industry, understand environmental health and safety management system, explain humanity health and safety aspects. Let's start with the concept of health, safety and environment. Health and safety continues to be a priority issue for the oil and gas industry and a determining factor in its overall success. Exploitation of offshore hydrocarbon resources is inherently hazardous, and those involved in the industry apply significant effort to managing health and safety risk and achieving good levels of health and safety performance. The approach to health and safety management in oil and gas industry has been shaped by significant learning over the years to the point where we have an exemplar major hazard regulatory regime driving responsible and effective major hazard management. A number of initiatives have been implemented to address air, water and land use impacts associated with oil and gas production nationally. These policies range from the implementation of mandatory emissions limits on oil and gas operation to voluntary programs and actions. Some of these activities encompasses best management practices used by industry to reduce environmental releases. The oil and gas industry recognizes that some health and safety hazards are inherent in its operations and products. Companies in the industry have made many commitments to achieve excellence in managing these risks. Often these commitments go well beyond regulatory obligations. The health and safety performance indicators described are generally recognized as good indicators that may help companies manage operations and promote improvements in health and safety performance. Industry and its products have an impact on the natural resource base of civilization through the entire cycle of raw materials exploration and extraction, transformation into products, energy consumption, waste generation, and the use and disposal of products by consumers. These impacts may be positive, enhancing the quality of a resource or extending its uses, or they may be negative as a result of processed and product pollution and of depletion or degradation of resources. Industry also responded to these problems by developing new technologies and industrial processes designed to reduce pollution and other adverse environmental impacts. Let us now discuss the health effects of pollutants. Oil and natural gas production facilities emit pollutants such as hazardous air pollutants HAPs and volatile organic compounds VOC. These pollutants can contribute to health problems that may affect facility employees and the community. While state, local and tribal regulation limit the amount of emissions from oil and natural gas production facilities, dangerous releases of HAPs can occur if an oil and natural gas production facility does not operate in compliance with regulation. Oil and natural gas production emits benzene, toluenes, ethyl benzene and xylenes (BTEX), as well as N-hexane and VOC. Benzene. Exposure to benzene may cause irritation of the skin, eyes and upper respiratory tract, blister on the skin. Exposure to benzene over a long period of time may cause blood disorders. Toluene. Exposure to toluene over a long time may cause nervous system effects, irritation of the skin, eyes and respiratory tract, dizziness, headaches. VOC. It is released during the production of oil and natural gas. The chemicals in VOC can form ground-level ozone smoke, which can cause breathing difficulties, especially with those who are young, elderly, or have existing respiratory problems such as asthma. Oil and natural gas production facilities can reduce air pollution. There are some techniques which can reduce air pollution. Make connections. Get to know local oil and natural gas production facility owners and operators. They know best about the processes used at their facilities and the regulation with which they must comply. Keep local media aware of progress by sending them updates. Publicity can reward success and attract more public involvement. One way to get to know local oil and natural gas facility owners and operators would be to learn about and promote the use of desiccant dehydrators. Make a plan. One idea is to form a work group that includes local owners and operators to develop and implement workable pollution reduction plans. Locate resources. Find state, local and tribal contacts. Use the resources listed on these web pages to get help with analysis, technical information, equipment, training and funding. reward facilities, encourage owners and operations to become natural gas partners, use media connections to provide coverage for successful efforts. Positive publicity can mean increased business. Visibly displayed awards or certificates may also improve business. Now moving on to the next topic, we will study the hazards in oil and gas industry. Although flammable and toxic gas hazards are generally well understood amongst operators, technicians and safety personnel working within the oil and gas industry, continuous training and refreshment of knowledge is essential to avoid potential incidents linked to complacency or misguided actions. New personnel may be assigned to work activities in potentially hazardous areas with only very brief training in the basis of gas hazard and the operation of detection equipment. The following is a basic introduction to gases and associated hazards. What is gas? The name gas comes from the word chaos, which neatly summarizes the main features of the simplest state of matter. A gas is a swarm of particles moving randomly and chaotically, constantly colliding with each other and the walls of any container. The real volume of the particles is minute compared to the total space which they occupy, and this is why gases fill any available volume and are readily compressed. The average speeds of gas molecules are of the order of hundreds of meters per second, and they are colliding with each other billions of times per second. This is why gases mixes rapidly and why they exert pressure. The constant motion is easily demonstrated by releasing a small amount of odorous gas in a room. Within seconds, the gas can be smelled in all parts of the room. These properties apply to substances which are normally gaseous and to vapors from evaporated liquids. A volume of any gas at the same temperature and pressure contains the same number of molecules irrespective of what the gas is. This means that measuring gas by volume is very convenient. Gas measurements at higher levels are in percent volume and at lower levels parts per million, ppm volume. Whilst different gases have different densities, they do not totally separate into layers according to their density. Heavy gases, hydrogen sulfide, tend to sink, and light gases, methane, tend to rise, but their constant motion means that there is continuous mixing. They do not behave like liquids. So in a room where there is a natural gas methane leak, the gas will tend to rise because it is lighter than air, but the constant motion means that there will be a considerable concentration at flow level. This will happen in perfectly still conditions, but if there are any air currents, the mixing will be increased. Combustion of gases and vapors. Most organic chemical compounds will burn. Burning is a simple chemical reaction in which oxygen from the atmosphere reacts rapidly with a substance, producing heat. The simplest organic compounds are those known as hydrocarbons, and these are the main constituents of crude oil or gas. These compounds are composed of carbons and hydrogen, the simplest hydrocarbon being methane, each molecule of which consists of one carbon atom and 4 hydrogen atoms. It is the first compound in the family known as alkanes. The physical properties of alkanes change with increasing number of carbon atoms in the molecule, those with 1 to 4 being gases, those with 5 to 10 being volatile liquids, those with 11 to 18 being heavier fuel oils, and those with 19 to 40 being lubricating oils. In most industrial environments where there is a risk of explosion or fire because of the presence of flammable gases or vapors, a mixture of compounds is likely to be encountered. In the petrochemical industry, the raw materials are a mixture of chemicals, many of which are decomposing naturally or are being altered by the processes. For example, crude oil is separated into many materials using processes referred to as fractionation or fractional distillation. Fractions are further converted using processes such as cracking or catalytic reforming. Flammable hazards are therefore likely to be presented by many substances on a typical oil refining plant. Explosive risk. In order for gas or vapor to ignite, there must be an ignition source, typically a spark, flame or hot surface, and oxygen. For ignition to take place, the concentration of gas or vapor in air must be at a level such that the fuel and oxygen can react chemically. The power of the explosion depends on the fuel and its concentration in the atmosphere. The relationship between fuel-air ignition is illustrated in the fire triangle. The fire tetrahedron concept has been introduced recently to illustrate the risk of fires being sustained due to chemical reaction. With most types of fire, the original fire triangles model works well. Removing one element of the triangle, fuel, oxygen or ignition source, will prevent a fire occurring. However, when the fire involves burning metals like lithium or magnesium, using water to extinguish the fire could result in it getting hotter or even exploding. This is because such metals can react with water in an exothermic reaction to produce flammable hydrogen gas. Toxic risk. Gases and vapors released from oil and gas production and processing activities can, under many circumstances, have harmful effects to workers exposed to them by inhalation, being absorbed through the skin or swallowed. Person exposed to harmful substances may develop illnesses, for example cancer, many years after the first exposure. Many toxic substances are dangerous to health in concentration as little as 1 ppm. Given that 10,000 ppm is equivalent to 1% volume of any space, it can be seen that an extremely low concentration of some toxic gases can present a hazard to health. It is worth noting that most flammable gas hazards occur when the concentration of gases or vapors exceed 10,000 ppm, 1% volume in air or higher. In contrast, toxic gases typically need to be detected in sub 100 ppm, 0.01% volume levels to protect personnel. Oil and gas companies need to handle operational risk. Most oil and gas companies would agree that the most significant challenge for their enterprise is management of information. Oil and gas companies continue to work to be able to create intelligence from the massive amount of technical and business data, both structured and unstructured, that they have collected. Prevention of non-compliance. With increasing regulatory pressure, oil and gas companies cannot afford the risk of being non-compliant. More stringent requirements for timely reporting on operations and accidents might be required, as well as risk mitigation plans for critical operations like drilling. The environmental issue. Industrial productions contributes goods, services and jobs, but it is also a major source of pollution and waste. This pollution and waste can be classified into 6 categories. Toxic chemicals criteria, air contaminants, greenhouse gases, hazardous waste, non-hazardous waste and radioactive waste. Toxic chemicals. These substances are hazardous to human health and the environment. In 2004, industrial facilities generated over 5 million tons of toxic chemicals as production-related pollutants and waste. Greenhouse gases. These gases, which include carbon dioxide, CO2, methane and nitrous oxide, are linked to global climate change. Industrial energy use is a major source of CO2 emissions, roughly on a par with the CO2 emissions arising from energy use in the agriculture, commercial and residential sectors combined. Hazardous waste. Hazardous waste are industrial waste streams that may contain more than a single chemical or substance. They are typically defined by characteristics such as ignitability, reactivity, corrosivity, and toxicity. Comparable data for hazardous waste generation and management are currently lacking, making it difficult to discern trends. Let us now know the meaning of Environmental Health and Safety Management System. An Environment Health and Safety Management System (EHSMS) is required for Category A projects and may be required for Category B projects that have sensitive or special issues. This will be determined by IFC projects review staff. Project sponsor management will develop formal procedures, programs, plans, strategies, budgets and pollution reduction targets to identify potential hazards, assess risk and to eliminate or minimize the potential impacts of oil and gas activities on the environment and to humans. The objectives of the Environment, Health and Safety Management System is to demonstrate due diligence in complying with all laws, regulation and IFC requirements, control risk, minimize adverse environmental impacts, promote worker safety, continuously improve environmental, health and safety performance. An action plan AP is required derived from the EHSMS. The AP consists of the set of mitigation, management, monitoring and institutional measures to be taken during implementation and operation to eliminate adverse environmental, health, safety and social impacts, offset them or reduce them to acceptable levels. Environmental guidelines. Maximum emission levels for the design and operation of each project must be based on country legislation, and these guidelines as applied to local condition and which have been established through the environmental assessment EA process. The emission level selected must be justified in the EA and acceptable to IFC. The following are emission levels normally acceptable to IFC in making decisions regarding provisions of IFC assistance. Any deviations from these levels must be described and justified. Solid waste. Solid waste such as packaging material, containers, discarded and or damaged pipe and drill bits and leftover construction materials are to be taken ashore and appropriately recycled, reused or disposed.
Morocco is treating old things in a new way, here at Omaza Solid Waste Plant outside the country's capital, Rabat. The landfill is the first of what Morocco says will soon be environmentally safer waste plants in the country.
By 2014, all dumps will be restored, meaning they will be covered and closed. And by 2020, at the latest, all urban centers will have solid waste plants. This is a big step toward protecting the environment.
Morocco produces 5 to 6 million tons of waste a year, and it usually goes to informal dumps like this one on the outskirts of Rabat. The dumps are bad for the environment and people's health, say government officials. To reverse this, it's put in place a national program for waste management, which is creating sites like Omaza in order to improve trash collection and processing.
This is a waste plant that respects the environment and puts no pollution in the environment, meaning that lixiviates, the liquid waste, are prevented from entering the soil and are treated by inverse osmosis.
The Omaza landfill receives 1,300 tons of garbage a day from 13 different communities, including from the capital, Rabat. At the new landfill, an initial sorting process loosely separates organic waste from plastics, carton, metals, and glass. The separated waste then travels up a conveyor belt to a second floor for a more thorough sorting by hand. Recyclables are bagged for wholesale to companies that reuse the material, and the remaining organic waste is dumped into this enormous compost pile. As part of the new waste program, supported with World Bank funds, trash collectors from old dump sites are offered jobs at Omaza, where they work under the protection of a union they run.
Now it is better. Trash used to be dumped everywhere. Now there are rules.
The workers say sorting in one place and having regular salaries make a messy job less difficult.
Naturally occurring radioactive materials NORMS norms. The norm accumulation process is very gradual and many times unpredictable. Radiation surveys of equipment and sites should be undertaken every 5 years or when equipment is to be taken out of service for maintenance. Facilities are considered impacted if surface levels are greater than 4.0 BQ by cm2 for gamma or beta radiation and 0.4 BQ by cm2 for alpha radiation. Environmental best practices. Some important aspects that should be considered are drilling management. Use directional drilling, horizontal and extended reach techniques to avoid sensitive surface areas and to gain access to the reservoir from less sensitive surface areas. Where this is not possible, provide an explanation. Use closed looped system. Reduce the hydrocarbon content of cuttings by mechanical, chemical or thermal clean-up treatment where possible, or transport them to shore for treatment or disposal, or consider annulus or downhole injection. Use enhanced solids control system to reduce the amount of waste from circulation system and the amount of dilution. Produced water management. Consider alternatives to surface discharge of produced water such as reinjection, onshore treatment and disposal, and downhole separation of oil and water. Minimize the quantity and reduce the toxicity of discharged produced water. Select the least hazardous chemicals in order to minimize produced water toxicity. Reuse produced water and recover oil from processed wastewater prior to disposal. Chemical management. Use the chemical hazard assessment and risk management techniques to evaluate chemicals and their effects and utilize the least toxic and hazardous chemicals considering persistence or bioaccumulation aspects. Use low toxicity lubricant additives to reduce the overall toxicity of drilling fluids where possible. Human health and safety aspects. It is important that a safe working environment exists since this minimizes both the potential for injuries and death and the risk of accidents leading to environmental pollution. All activities are to be conducted in a safe and skillful manner with staff appropriately trained and equipment maintained in safe condition. Safety cases should be developed for appropriate facilities. Workplace air quality. Protective respiratory equipment must be used by employees when exposure levels for welding, fumes, solvents and other materials present in the workplace exceed local or internationally accepted standards or threshold limit values TLVs. Workplace noise. Feasible administrative and engineering controls including sound, insulated equipment and control rooms should be employed to reduce the average noise level in normal work areas. Plant equipment should be well maintained to minimize noise levels. Personnel must use hearing protection when exposed to noise levels above 85 dB. Work in confined spaces. Prior to entry and occupancy, all confined spaces, example tanks, sumps, vessels, sewers, excavations must be tested for the presence of toxic, flammable and explosive gases or vapors and for the lack of oxygen. Adequate ventilation must be provided before entry and during occupancy of these spaces. Personnel must use air-supplied respirators when working in confined spaces, which may become contaminated or deficient in oxygen during the period of occupancy. Training. Training plans, programs and practices are to be established and carried out for all personnel. They will include training on basic safety procedures and on environmental issues and job-specific safety procedures according to their duties and responsibilities. Training will include instruction on the operation of equipment, emergency survival and firefighting, how to read and understand material safety data sheets, MSDS, and safe chemical handling emergency response procedures. Now in the end, let us summarize what we have learned in this lecture. The oil and gas industry recognizes that some health and safety hazards are inherent in its operations and products. Companies in the industry have made many commitments to achieve excellence in managing these risks. A volume of any gas at the same temperature and pressure contains the same number of molecules irrespective of what the gas is. This means that measuring gas by volume is very convenient. Gas measurements at higher levels are in percent volume and at lower levels part per million ppm volume. The physical properties of alkanes change with increasing number of carbon atoms in the molecule, those with 1 to 4 being gases, those with 5 to 10 being volatile liquids, those with 11 to 18 being heavier fuels, oils, and those with 19 to 40 being lubricating oils. Gases and vapors released from oil and gas production and processing activities and can, under many circumstances, have harmful effects to workers exposed to them by inhalation, being absorbed through the skin or swallowed. Feasible administrative and engineering controls including sound insulated equipment and control rooms should be employed to reduce the average noise level in normal work areas. Plant equipment should be well maintained to minimize noise levels. Maximize emission levels for the design and operation of each project must be based on country legislation, and these guidelines as applied to local condition and which have been established through the environmental assessment EA process.